Hi everyone, I'm Andrea D'Amico and I am a PhD student at Politecnico di Torino under the supervision of Professor Vittorio Curri. Today I'm going to introduce my research activity with the name Analytical Models and AI for Open Optical Networking. My research activity is focused on physical layer-aware modeling, simulation, software implementation, and artificial intelligence method applied to quality of transmission estimation in optical networks. The flow of my research starts with the problem definition and modeling. Then there is a step of software implementation and experimental validation. And the objective of my research is the quality of transmission light path computation, the network planning and controlling, and the optimization and forecasting. As a matter of fact, all the optical infrastructure are experiencing a continuously increasing traffic request. This is due to new technology as 5G, Internet of Things, augmented reality, metaverse, and cloud. More than 90% of these connections goes through optical fibers in terms of amounts and distance. To catch up on the increase of traffic requests, there are two viable solutions: building new infrastructure and optimize the already in place optical network using cutting-edge transmission technologies. For both these purposes, it is required the availability of an accurate optical network digital twin. This is the case of GenPy, an open-source Python library which, given the configuration of the network, the nominal values of the physical parameter, and the data from the telemetry of the network, can be used to the quality of transmission, light path computation and feasibility, quality of transmission forecasting, failure detection and localization and estimation, and of course, network planning and controlling. For this reason, it has earned an increasing interest from optical operators and vendors around the world. Working within the GenPy framework, I summarize my research activity in 3 consecutive steps. First, the modeling and implementation consists of the physical differential equation analysis and solving, and the software implementation and optimization. Then these implementations are validated in the laboratory through dedicated setup. Additionally, AI and heuristic applications are verified for optimization purposes. Finally, GenPy is validated in commercial testbed for cutting-edge transmission technologies as dynamic and flexible signal propagation and Nyquist multi-subcarrier transmission. In this presentation, I will describe an advanced GenPy application where an AI solution is leveraged to increase the accuracy of the digital twin. In this use case, an optical line system has been set up and real quality of transmission measurements have been collected in order to train and test a deep neural network, which enhances the quality of transmission predictions of GenPy in case of dynamic spectral load. As can be observed in the shown figures, the deep neural network provides a smaller error in the prediction of both the signal and noise powers for all the investigated channels, giving in the end a significant improvement of the quality of transmission estimation. In conclusion, to summarize my PhD experience, I want to highlight my related achievements. I was invited as a speaker at the ACP IPOC 2020. I was co-author at the Fiber Optic Sensing in Geoscience workshop. I was invited to other 2 workshops. One is the Next Generation Cloud Infrastructure workshop of Microsoft, and then the Networking Research Summit at Google. I was involved in experimental collaboration with the Orange Labs, and I had an internship at the NEC Labs, Princeton, US. As a result of my research activity, I have published a total of 31 articles, 11 of which are journal papers. These publications have gained significant interest within the community, as proved by the number of citations and downloads. Since 2018, I'm contributing to the open source Python library GenPy as a main software contributor for the physical layer-aware simulations. Also, I'm proudly the current president of the Polito Optical Student Chapter.